Hello everyone, my name is Isaac Gora here with the project team at Sigma Engineering, and today we're going to be presenting our final design for the outdoor sports field complex for the city of Brandon. Presenting with me today will be Zach, Alexis, Tuan, Anthony, Nair, and Jesse. The agenda for today will include the project background, key features of the site, our technical works, including utilities, some discussion about the construction cost and schedule, and I'll give a brief closing statement. In 2014, the City Board replayed for the second time, destroying City of Brandon's Optimus Park, which was a multi-field soccer complex. In 2015, a feasibility study was conducted, which determined that the site at First Street and Veterans Way was eligible for future development. In 2017, the City commissioned an updated master plan, including features noted on the slide. And in 2019, a heritage resource impact assessment was completed, which cleared the site for construction. The site's key features include active facilities such as soccer fields of varying sizes, two cricket pitches, disc golf adjacent to the ponds, an event space, and a playground. The buildings include the clubhouse and maintenance garage, and transportation features include on-site parking for 400 vehicles and active transportation paths. And with that, I'll pass it off to Anthony. We'll talk about the geotechnical works.
Thanks, Isaac. So our geotechnical group was involved with the designs of the following structures. So we designed the dike for a 1 in 300 year flood event. So we proposed it to construct it from locally sourced clay fill, which is both feasible and cost-effective solution. We also designed the foundations for both the buildings. We designed shallow footings for the clubhouse and a slab on grade for the maintenance garage. And in the bottom of the slide, you could see just a cross section of the dike, but a more detailed drawing is provided in the final report. Next slide, please. So we designed the pavements as well for the site access roadway, emergency access roadway, the parking lots, and the sidewalks and trails. Once again, a sample drawing is provided on the bottom of the slide. And last but not least, we also graded the site to ensure that the drainage requirements are met, and we also balanced the earthwork cut and fill volumes while doing that, and we actually got really good results. So passing it off to Zach to talk about the hydrotechnical component.
Thanks, Anthony. So work related to land drainage included the design of a major and minor land drainage system and 2 retention ponds. The hydrotechnical team conducted a study of the existing site topography and designed the system through precipitation runoff to the retention ponds. And I'll give a brief overview of these 3 elements in the next few slides. The major system is comprised of a system of swales that run throughout the park, which moved water from the fields and parking lots to catch basins, and was designed to minimize elevation changes to allow the minor system to drain into the retention ponds without the need for pumps. The minor system was first designed using an approximate analytical method based on the rational method and Manning's equation, with City of Brandon standards used for design criteria. And the behavior of the system was then verified using an EPA swim model. 2 naturalized retention ponds were designed, including the size, cross-section details, and outlet structures, and are designed to retain storm water as well as improve water quality before being discharged into the Assiniboine River. The behavior of the ponds were modeled in swim to ensure that they could handle the 5-year and 100-year storm with appropriate drawdown time and freeboard. And now I'll let Alexis discuss work related to water services.
Thanks, Zach. So first for water services, we have the wastewater sewer system for the site, which was designed as a gravity sewer. It conveys the peak wet weather flow of wastewater from the clubhouse and maintenance garage to the sewer main under Veterans Way. The pipe sizes and slopes are determined using Manning's equation. Next slide, please. Next up is the water distribution network, which routes water from the water main under Veterans Way to the clubhouse, maintenance garage, and 2 fire hydrants on site. The design flow for the system is the sum of the maximum day demand and the required fire flow. The network was modeled in EPA net with pipe size to maintain guideline specified velocity requirements and pressure heads. Next slide, please. Lastly, we have the irrigation system, which waters the sports fields on site. The irrigation pond in the northwest corner of the site acts as the primary water source for the fields. A drought simulation indicated that it was necessary to use the Assiniboine River as a supplementary water source for the system. The whole system was modeled in EPA net, and the pipes were sized so as to maintain required pressure heads at approximate extreme sprinkler head locations. And that's all for water utilities. So now I'll pass things off to Nair for the transportation elements of the project.
Thank you, Alexis. For the transportation section, we started with a traffic impact analysis where we determined the level of service of First Street and Veterans Way using synchro for each lane, and the lowest level of service lane had level of service C. Additionally, the level of service of the proposed intersection post-transportation design was at level of service A. Next slide, please. Now moving to the design phase, we propose adding a road painted median to accommodate for a left turn lane, which will result in a higher level of service and safety, Additionally, we extended the merge lane from First Street to accommodate vehicles that are turning right into the site while maintaining the same traffic going eastbound. Next slide, please. We have designed 4 different parking lots that will total to 400 vehicle stalls, where each lot will accommodate approximately 100 stalls, and that includes 7 to 8 handicap stalls, totaling 31 handicap stalls for all parking lots. Finally, we designed a multi-purpose trail that is a little above 3 kilometers long. With that, the transportation section concludes, and I'll be passing it to Towan for the structural portion of the project.
Thank you, Nair. So the main structural works of this project is the clubhouse and the maintenance garage. Both these buildings are steel superstructure. The clubhouse contains 4 change rooms, which are accessible from the outside, 2 washrooms, an office space, and event space. Additionally, there's a canteen area with a commercial kitchen. So we use the Manitoba building code to determine the design load in order to select the beams and column size. Next slide, please. The maintenance garage contains a spacious storage of 50 square meters for vehicles and equipment. Additionally, it includes an office space, a 10 by 12 feet overhead garage door. Same as the clubhouse, the Manitoba building code was used to select the beams and column size for the maintenance garage. I'll pass it off to Jesse to discuss the environmental work.
Thank you, Towan. A preliminary assessment of the project's effects on the environment was conducted. Various valuable ecosystem components were considered, including the heritage resource, which was concluded not to be a concern. Sigma Engineering determined 4 applicable City of Brandon bylaws to which the project should abide. Sigma Engineering is of the opinion that this is a Class 2 project per Manitoba's Environmental Act and is to be confirmed by the Environmental Approvals Branch of Manitoba Conservation and Climate. Federal regulations were addressed based on the project details. Sigma Engineering provided mitigation measures for reducing the pH of the soil and maintaining the water quality of the ponds. Next slide, please. The land drainage system, the water main, and the wastewater collection have been previously discussed by Alexis and Zach. Details for nearby gas, fiber optics, and power lines were addressed about their location and implementation. Installation of all utilities will follow their respective guidelines and standards. I'll now pass it off to Isaac for the summary of the Class C cost estimate.
Thank you, Jesse. So here we have a breakdown of our Class C cost estimate with rolled up items and detailed estimates presented in our report for a total project cost of $6,238,713. There is a variance in accuracy as to the Class C cost estimate of plus 35% to negative 20% as shown. The construction phasing and sequencing is shown on the left as we have delineated the site into 6 phases with durations and estimated costs as shown on the table on the right. With that, we thank you for listening.